second day of the Pragma Student Workshop 2021. And the Pragma Student Workshop, which hosted by Universitas YRC, will provide students with the opportunity to discuss and share their own research project with their peers. And aside from that, the workshop will include discussion that are relevant to the students and will include experts from the Pragma community as a mentors. This event will be held in 2 days, on 9 and 10 December 2021. Contains three main sections, which are keynotes, workshops, and student presentation. The keynote session invites experts from Pragma community who will discuss the current issue and technology application and future directions that related to machine learning and artificial intelligence. The workshop session consists of series of workshops designed to develop students' soft and technical abilities in the areas of research and technology. At the end, some selected students will share their research project in the student presentation session. Before we start, firstly, we would like to say thank you to our keynote speaker today, Dr. Anusa Achutan from University Science Malaysia, and to Associate Professor Dr. Nurul Malim, also from University Science Malaysia. Thank you for your presence today, Dr. Anusa and Dr. Nurul Malim. Ladies and gentlemen, let's say Basmala to open and for smooth running of Pragma Student Workshop today. Bismillahirrahmanirrahim. Okay, let me describe today's agenda. First, we will have the keynote session. This session will be led by Dr. Sri Kusri. She will be the moderator of this session. And the second, we have the student presentation session. We will have about the 8 student presenters today, and this session will be led by the Wasapun Watanaki Sunton from Naras Science Institute and Technology. And lastly, we have a workshop session that would be 2 parallel sessions of the workshops. The first workshop will talk about the cloud technology delivered by Prapapon Ratana Thamrong from Thammasat University, Thailand. And the second workshop will be talk about deep learning using TensorFlow delivered by Chandra Prasetya Utomo and Muhammad Rahman from Universitas YRC. After the workshop session, there are award and closing session. In this session, we will announce the best student presenter at Pragma Student Workshop 2021, and we wish that you can join with us in this session. Okay, before we start the keynote session, we have a photo session. I hope all of the participants can open their camera, and our staff will help us to capture the photo. Okay, yeah, we have about 62 participants currently, and we hope that you can open your camera. On the count of 3, I will take the photos. Okay, we have 3 pages. Okay, page number 1. On the count of 3. 1, 2, 3. Smile. Okay. Okay. Page number 2. Okay. On the count of 3. 1, 2, 3. Smile. Okay. The last page. 1, 2, 3. Okay. Smile. Thank you. Okay, now we will move to the first agenda. I would like to invite Dr. Sri Kusri to lead the keynote sessions. Dr. Sri, the time is yours.
Thank you, Pak Fatur. Dear Honorable Keynote Speaker, Dr. Anusa Achutan and Dr. Nurul Hasimah Malim, all speakers and guests, here is Nan, Boom, Gohei, and Yeah, and all enthusiastic students who joined this Pragma Students Workshop 2021. Good morning to you all. I hope all of you are well. Today we have two keynote speakers, as have been mentioned, Pak Fatur. There are Dr. Anusa Achutan and Dr. Nurul Hasimah Malim, both from University Science Malaysia. For your information, we, Universitas Yarsi and University Science Malaysia, we have a memorandum of understanding in research, education, and training program since 2019. Yeah, from that time, we have held student exchange, research mentoring, and inviting speakers for our webinar. Yesterday, we have heard from two keynote speakers, Peter Asperger and Prof. Heru Suhartanto, about Pragma and fundamental lessons for students, such as the importance of cooperation and collaboration to solve society problems, and the relevance of mastering soft skills. Today, we will listen and discuss more technical issues regarding the theme of the event, practical machine learning and artificial intelligence from Pragma community. Each keynote speaker will have about 20 minutes presentation, and then we have question and answer until 9 o'clock. Our first keynote speaker today is Dr. Anusa Achutan. Please, Pak Slamet, share Dr. Anusa short CV. Yeah, Dr. Anusa Achutan is a senior lecturer at School of Computer Science of University Science Malaysia. She received her PhD in 2016, specializing in computer vision and medical image analysis from University Science Malaysia. Her main research publications are in areas of computational neuroscience, knowledge-guided image analysis, biomarker analysis for neurological disorders and aging, machine learning, and computer vision. She is a member of IEEE, ISMRM, and IACSIT. Besides research work, Dr. Anusa is also very passionate about online teaching and learning resources. She has developed a few online learning modules. Please, Dr. Anusa, time is yours.
Yeah, thank you so much, Dr. Sri, for the warm welcome. Okay, so how's everyone today? Hope everyone is good over there. So let me start to share my slide for today talk. Okay. Hope you all can see this. Yes.
Yes.
Okay.
But
is this
not? Yeah.
Okay. Is this okay?
Yeah.
Okay. So let me rearrange some of the tools. Okay. Okay. So yeah, okay, as been introduced earlier by Dr. Sri, okay, I'm Anusha, okay, and I'm from School of Computer Sciences, USM. Okay, and my major is more on computer vision and image processing. So today I would like to take this opportunity to introduce, okay, or to expose what I have been doing so far, which actually kind of marrying AI in medical applications. So I will introduce some key concepts and the efforts that have been carried out so far. Okay, so yeah. So before going further into what have been done with AI in medical applications, I would just maybe would like to take 1 minute to quickly introduce what is computer vision and image processing. Okay, so basically what we do in computer vision and image processing. So there are few focus here, focus area or aim. So the first one, okay, usually, obviously when we say computer vision and image processing, we are dealing with images. So my data is images, okay? So you have to use image as your data set. So using images, there are few objectives that we can achieve. Okay, the first one would be on classification. Okay, that means given a full image, okay, given any image, you try to predict, okay, what is the major theme or the major content of the particular image. For example, this is the whole image of having a cat. So obviously the system or the application supposed to name this image as cat, okay? So that we call it as classification. So we classify the whole image into groups, either cats or any other objects in the image. The second part or the second focus would be to not only classify the image or the main object, we also want to localize. Localize meaning to say we want to find the location, estimate the approximate location of the object. So here, we already know this is a cat image, but now I'm trying to localize it, approximate where is the cat is situated in this particular image. Okay, so that is classification plus localization. Then we go a bit more deeper into the process where we don't just classify, localize. If let's say there are multiple objects, okay, I have seen only one object as a cat. Let's say in your image, you have multiple objects. Okay, for example, here you have cat, you have dog, you have duck. Okay, as a human, when I see this image, I know where is the duck, where's the dog, duck, and the cat, right? But now we are making the system or the application to identify automatically where is the cat, where is the duck, and where is the dog, and label it accordingly. Okay, it's not just localized, and then you have to identify this is dog, this is cat, and this is a duck. Okay, that is another perspective when we are looking at computer vision applications. And finally, we have a more refined application. We don't just estimate the location, but we exactly outline the shape, the size of the object. So we call that as segmentation. Instant segmentation meaning to say the particular object segmentation. Okay, segmentation is like a delineation, you outline. So automatically the system supposed to outline the shape of the particular object. So here it will be very helpful. It's like having a computer which behave exactly like human in identifying the object, not only the location, but also the shape and the size and the colors also even. Okay, so this is what my area fall in between. So I'm doing all this classification up to segmentations. Okay, so this is in general. So having this understanding of this theoretical background to computer vision, let's see what I'm doing, okay, on this field, but more focusing on medical applications. Okay, summarizing what I have done so far when I initiate my efforts or my research interest in this area. So I started in 2005, okay, which actually I started with my master's research project. Okay, so in 2005, I was actually working with some radiologists from hospitals to get the data set. And actually the focus of the case was on the bladder tumor, okay, and also thyroid tumor. So having introduced what is computer vision is more like a segmentation problem. You have to segment the tumor. That means I need to know the shape, the size of the tumor. That what I initiated in 2005. Then later on, for my PhD, I went into the brain. Okay, identifying a structure in the brain, which called as hippocampus. Again, is a segmentation problem. And why this structure, hippocampus? Because this structure relates to memory-related illnesses or disease like dementia, Alzheimer. Okay, so it is said in the readings that the size and the shape of this hippocampus relate to the severity of Alzheimer, dementia, and even epilepsy. So that's why we need to do segmentation to get the size and the shape. And later part in 2016, after I came to USM, I worked with various collaborators in USM and also outside to apply whatever computer vision methods in doing segmentation, localization, and various kind of medical applications. Some of it like liver segmentation, liver tumor segmentation, and on acquisition model like we say medical physics on the enhancement of the signal images. And then in 2018, I ventured into another new application called extractography, which I will explain later. So this is actually not looking just at the structure in the brain. That means just not like hippocampus, but we are seeing at the networks in the brain. Okay, I hope everyone knows that in the brain, when at least you are doing thinking process, there are millions neurons being fired in order for you to do the thinking process or any ability, even reading, right, in the brain. So there are various firing networks, neurons. This goes back to biology. So in imaging, we are trying to capture the neuron firing. So it's like giving a networks of pathway where the neuron is being fired when you are doing something. So in the brain, we are trying to do and visualize that with diffusion tractography applications. So this is one of the current work that I'm actively doing right now. Okay, so this is to summarize my research so far. Okay, so let's see now how for each application the AI is coming in, okay, or the machine learning, for example, how the methods is being used. So let's see the first part, okay, on structural segmentation, I would say. Structural means object segmentation, but for medical application, we would like to call it structures. We don't call it as objects. Okay, so when we see structural segmentation in medical images, so I have worked with bladder, brain tumors. I'm working right now. One of my PhD students is doing that. We have worked with liver tumor and then some structures in the brain, like hippocampus, for example. And then the main aim is segmentation, to delineate or to really outline the structure. And then after that, we do further analysis, for example, like the size, the shape, the volume. Okay, we can get 3D data, not only seeing a single image. We can construct like a 3D model, like an object, because medical image application allows that. We can construct 3D, and then like we can see really how big is that particular structure. So for bladder segmentation, what method that have been applied is basically using classification, more on the probabilistic based classification on this structure. Okay, and then we have on the liver segmentation. Okay, so this is a more recent work. My student have adapted deep learning. I hope all of you are aware, because deep learning is the current focus of the AI community, right? So we have adapted deep learning method to segment the tumor and also the liver. Okay, so that is one of the another application we have adapted. And then for tumor segmentation, like brain tumor, bladder tumor, we also have tested with deep learning methods and optimization theory. Why this optimization theory is to, when we have deep learning, there are a lot of hyperparameters involved in deep learning. So the focus of optimization is to optimize the best selection of parameter to give the best results. Okay, and then when we say subcortical meaning to say small structures in the brain. Okay, actually this, if you can see here, this is the brain. Actually, if inside the brain there are many other small structure relate to every part of human activity. So I have focused on hippocampus that I've used, we call as point set registration based method, is again a classification based method to register the location of the particular structures and to segment it using level set method. That's one of the method. So eventually when you segment that, actually you can construct a 3D model, if you can see on the right hand side. So from here, obviously you can see how big is the structure, what is the shape. You can see for some cases, okay, the shape is like, it's not a good shape, it's quite big or quite thin, for example. So from here, it helps the doctor to identify, to predict what is the treatment or what is the diagnosis for the particular patient. Okay, so this is more on the structural segmentation. Then the second focus on image enhancement. Okay, image enhancement meaning to say some images, when they obtain either from the camera or the scanning machine from the hospitals, the images are not clear. Okay, so it's very hard for the computer vision application to predict, to segment, to localize. If let's say the image is noisy, so we can't actually make the computer vision to accurately segment the particular structure. So we must give a clean image, okay, an image with high readability, high quality. So in order to do that, we will apply image enhancement method. So some of the image enhancement method that have been used, okay, for medical physics images, like signal images on this right here, we have applied thresholding of the sinogram methods. And when come for brain imaging, we have tried to use optimization theory, okay, to optimize the characteristic of the images. And then for some of the tumor images, meta-heuristic optimization theory have been also applied to enhance the images. So this, on the enhancement method for the brain and tumor, this is considered as a current work my student is currently doing, and he have managed to publish this year actually. So this is an ongoing project that we are focusing at right now. Okay. So now that is on an enhancement. And now the most interesting part actually that I'm currently working on is interesting to see not only the structures, it's like shapes or the size of the structure in the brain. Now we want to go more deeper, okay, to see how actually the connection in the brain, you know, how is the connection of neurons in the brain? How does it fire from one place to another place? Let's say you are doing a reading, you know, actually in the medical facility, they can set up a scanning protocol where you can be doing something and you will be scanned at the same time. Okay, so that's interesting. They will give like maybe a piece of paper stick to the scanner machine. So you are actually being asked to read the paper and while the scanning is taking place. So during that time, you can see which part of the brain is being fired, you know. So a good firing, a good brain functionality says that you should have a very long line of structures. You shouldn't have broken. So if you have a broken pathway, it's like a road. Okay, the road must be clear without no obstruction. Okay, you can go from one point to another point towards the end. If let's say there's a cutting point, suddenly a broken road, that means that part of the brain is having some issues. Maybe lack of oxygen, maybe there's a tumor in the brain that is actually obstructing the pathway. So this allows for further analysis for the particular patient. Especially this is very helpful for stroke patients actually. So currently we are focusing on fuzzy systems, on actually constructing these pathways to come up with the best pathway, to see the direction and to see the source and destination of the pathway. And then the case study that we are working on is called a cerebral small vessel disease. That means this is small strokes. We call it that. There are strokes that cannot be seen actually. So sometimes people are stressed, minor stroke happens. So when that minor stroke happens, actually it cut off certain part, oxygen to certain part of the brain. So then some pathways are not working properly. So if you can detect earlier, then well, you can save the particular subject from further other issues. Okay, so that is the case study we are using to visualize this tractography. Okay. And some other minor projects that I'm also focusing on is on exergames, which we can also reflect as exercise games. Okay, so it's like a mobile-based exercise games. So currently some of the students have actually worked on developing like treasure hunt kinds of mobile games that actually to promote exercise routine, and from there you can calculate the calorie total step that the student have taken or the participant have taken. Okay, and then I am also working on mobile applications for diet recommender based on food images that you eat every day. You propose a diet and also exercise routine, and some on facial recognitions applications, for example, for door access. And also another ongoing project is on medical data analytics, meaning to say whatever data that you have about a patient that you collect for a community, you predict what you can foresee that will come another 5 or 10 years. For example, like COVID, right? If you can see the cases in particular community is actually very high density during certain time of the year, for example. So for next year, you can create something like an alert saying that, okay, for next year, this time frame for this particular area, please be careful. Okay. Okay, so yes, these are some of the grants that I'm working on with some of my collaborators from medical hospitals. And yeah, that's all. Due to time frame, I think I will stop here. Okay, thank you for listening.
Thank you, Dr. Anissa. Many very interesting research. So if you have any question, please save it in question and answer session. Let's now move forward to the next speech from Dr. Hasimah Nurul. Please, Pak Selamat. Yeah, Dr. Hasimah, Dr. Nurul Hasimah Ahmed Hasan Malim received her PhD in 2011 from University of Sheffield, United Kingdom. She is currently an associate professor and deputy dean of academic career and international in the School of Computer Science, University Science Malaysia. Nurul Malim is an active researcher in chemoinformatics, focusing on ligand-based virtual screening, which an important phase of drug discovery. To date, her works has been published in numerous journals and conferences with regard to 2D chemical structure searching. While maintaining her previous interest in chemical searching, he is also venturing into other wings of chemoinformatics by utilizing her data analytics skill. He is keen into applying computational computational methods such as machine learning, artificial intelligence, etc., in quantitative structure activity relationship, aiming at increasing the retrieval of actives in a chemical search or an accurate predictions of target activity, where her current focus is target prediction using deep learning Malaysia database of medical plants. He is also collaborating with Hospital University Science Malaysia in developing neuroimaging data platform named MyNeuroDB that includes a repository to host the neuroimaging records and also tools or algorithm for visualization and analytics. Dr. Hasima, time is yours.
Okay. Yes, thank you, Busri, which is Sri Jusri. Assalamualaikum warahmatullahi wabarakatuh. Very good morning. So let me share my presentation slide first. Okay. Is it now in presentation mode?
Yes, yes.
Good. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim, and very good morning to all of you. First of all, I would like to thank Pragma, Universitas ERC and Pragma for inviting me to become the keynote speaker for this session. So my topic today will be a bit different than my introduction just now, because I'm also venturing on ecological informatics. So I'll be talking about deep learning applications in ecological informatics. This is actually one of PhD works of one of PhD research by my PhD students. So basically all this is her work. So let's start with understanding what is ecological informatics. Okay. So this ecological informatics is emerging discipline that considers the data-intensive nature of the valuable information content on ecological data. So you can see that it's actually a overlap between ecology, ecological modeling, and you can see ecological informatics here. So you can see the ecology part is there, ecology modeling, and it becomes it is overlap with ecological informatics. So basically, for computer scientists, we are around this. We use a computational approach to solve ecology problem and to apply ecological modeling, and we use our computational approach like high performance computing, object-oriented data warehousing. So all these are related to computer science. Okay, so this is called they need to communicate results and decision making, and for research conservation and resource management. Okay. So sorry, my mom is behind. Okay. So the challenges of the what we are looking in the ecology problem that we are looking at is about harmful algae bloom prediction. So we are looking at how harmful algae bloom pollute the water resources, and since algae communities comprise of various species, so their characteristic is always different, so always changing. So that's why we say it differ in non-linear ways. So there is no trend, there's no anything. So it's always variable. It's like fluctuating, and it's so complex because it's all ever changing and very dynamic in growth. So we don't know what factor affect which factor. So how they are related and what is the impact. So we cannot have a stable correlation on that. So that's why it makes algae data hard to analyze and are not well understood, resulting in unreliable predictive models. So because these data, they are very on the short time scales, e.g. hours to days, because with current situation, researchers relies on in situ sensors. So they will go to the spot and periodically, like every 1 week or every 2 months. So what they get is a they get a long range time scale, but the fact is that this the characteristic of this algae changes every minute. So we need to capture the information. That's why this current situation, the in situ sensor where they put on the place and they come and they pick up the data, that one cannot be cannot detect, cannot allow us to come with a reliable prediction model. So what we need is real-time monitoring. So later I'll touch on the real-time monitoring. Okay, so existing ecological studies are lacking in several aspects. So in order to have a robust predictive modeling for algae growth, we need to highlight several issues. First, we need to understand which features to be mapped to the dynamic issues of the algae ecology. So we have a lot of features. Later we'll see the features. So which one that relates to the dynamicity issue of the algae? So that's what we were trying to find. And we need to come up with a suitable algae growth prediction modeling to tackle the dynamic characteristic for coastal studies. But because what we have so far is prediction model based on algae blooming in rivers and lakes. So what we are looking at is algae blooming in seawater, so in marine. So having an algorithm that works for freshwater might not work for seawater because the seawater has different characteristics. Sensors also, some sensors cannot survive in seawater as well. So there's a lot of issues there. So we are focusing our studies on the seawater, okay? And we are looking at two angles, from the features level and also algorithm level, to solve the dynamic issue. So with the current advancement of IoT, the process of monitoring water quality and eutrophication is basically algae bloom. The scenario of algae bloom is called eutrophication, because this algae bloom, the impact is it will kill the fishes or the living creatures inside, because it will close up. It will actually close up the surface water, and the light cannot go in. When the lights cannot go in, then there will be less oxygen down there, and it will be then the fishes less oxygen for the fishes and so on. So that's why they can die. The fishes can die. So we are working. We are working on the sensors where we have come up with the assembly and integrated sensors where we can now do data acquisition 24/7 actually. So we basically we can do every minute, so we can get the data, and we are doing the predictive modeling. So we are solving that part on the short time scales. Basically, we solve that by having a real-time monitoring system. Okay, so this is our real-time monitoring system. This is our development of our sensors kit, integrated sensors. We have 6 sensors inside this box, mounted into this box. Okay, and then we need to calibrate each of them every time we go and fix them up. Okay, so once we calibrate, then they will work on their own. So it is powered by solar panel. Okay, so we don't have to worry about the battery so much because it has solar panel, and there is a battery here that capture the solar panel power, and if it's at night, it will use this battery power lah. And then we put our sensors on fish plant on the sea. Oh, this is open seas, yeah. So we put it at the edge lah, towards the edge, And this is actually the part that hosts the sensors. So we put our sensors into the pipes and put the pipes into the water. That was our first setup lah. But unfortunately, that setup don't hold so long, and just only like 2 to 3 months, because it's open water. The current is very powerful, and the wave, so it broke the pipe. When it broke the pipe, then it affect our sensors. Okay, so we have another setup. Later I'll show you the setup. Okay, so what does this automated, what we have now is an automated water quality monitoring system that can acquire data every minute, and it will impact the industry. You will decrease the potential of catastrophic losses, and lower the production costs, and enhance the product quality. We are using low-cost sensors, and we have been able to integrate the sensors and getting the reading and so on. It's just the lifespan of the sensors that we are not sure yet, because we have not been able to put our sensors again since MCO. So we haven't tried how long can the sensors stay active in the fish plant before it collapses. So that one we haven't done yet. But all this work is inspired by the smart river monitoring system, where I think this is from previous work. So they do it in river, but we are doing it in seawater. But they don't have the prediction modeling element, but we have the prediction modeling element. Okay, so where do we put the prediction modeling element? Okay, so once we have our kit, and we acquire the data using our kit, then the data will go into our server, and we have a dashboard. We have a web system, so the dashboard showing all the current readings, and in graph, and also in logs, and then we can configure certain thresholds where, let's say for oxygen, we have dissolved oxygen as one of the sensor. Let's say we put dissolved oxygen. If dissolved oxygen below than 80, then alert the fish plant owner. So we have that features in our web system. So it will send the alert to the owner, and we are also currently building the apps for this. And the predictive modeling is will be put on top of this platform, where we want to predict what will happen in the next 10 days. So in order to predict, we need to have a data set that is related to this condition, like to seawater, exactly what we are measuring. So we have been able to capture the data from Tolo Harbor. So as a benchmark data set. So we are using that data set, and to do some predictive modeling on it, and after we have got the model, we'll put on top of our platform to predict the census reading for that location, for the location that we are working on. Okay, so so this work, in our work, we present proof that selecting the right features and utilizing time series, the predictive model we use deep learning later, are much better than for tackling issues of highly nonlinear and dynamic algae ecology. So basically, we want to prove this, and we have been able to prove this. So this is our framework, the steps that we took to do. So first, we need to we go through the literatures to find what are the parameters, what are the important parameters in predicting algae blooming or monitoring algae, parameters that people have been using, researchers have been using. And we also look into parameters used to measure water quality. Okay, so this is what we have from the algae blooming, and they are divided into factor category. So the first one is biological factor, physical factor, and chemical factor, and meteorological factor. So biological is more towards biological sensing like chlorophyll A. This one they have to go usually for in situ sensors. In situ sensors mean people have to go and take the sample, bring back to the lab, and process it. Okay, so that's what we call an in situ. So they have to be present at place to take the sample. So this can only be done by going there and taking the sample and going back to the lab and process the sample and get the value for chlorophyll A. So you cannot get it directly. But for physical factor like suspended solid, we now have sensors that actually used to measure water quality that can be used to replace the in situ parameters used by the ecology researchers, because they always go and collect data. Now they can sit at their place and just look at the screen, and they can see the readings of the data using our sensors lah. But mostly only physical factor sensors can do that. Chemical factor sensor, they still need to bring back their data. I mean, they still need to go and collect and bring back to lab for further experiment lah. Because they need to use reagent and so on. So that one we cannot do anything about it yet. Okay. So, but there have been works on coming up with chemical sensors. So we wait for, if there is one, then we can use. But at the moment, no. So these are based on the first stage. These are what we got. These two, okay. And then we found out that because we are focusing on the physical factor, because we have this, we want to use our sensors to know whether with these sensors is it enough for us to predict the algae blooming. So we put in more physical factor features into consideration. So in previous work by Lee, they only focus on 9 features. We now focus on 17 features, where we put in our sensors parameters into this, because we want to see if let's say we eliminate all the parameters later, can all with these 6 parameters coming from the sensor predict the algae blooming accurately or not. So that's what we are trying to do in the long run. So but for this presentation, we are focusing on the 17 parameters that we use here. These are the parameters that we are using. Okay, and we pre-process all this data, the Tolo Harbor data using the min-max normalization, so that all the data will fall into the range of 0 and 1. We use in linear interpolation to impute missing data, and we need to make sure that the data is in time series. The time series data was framed as supervised learning problem. So this is something that we must do, because we are doing regression. For machine learning, we are using regression type. So make data stationary. So because the data varies, they fluctuate. So we need to make it stationary using ADF or smooth forecasting. And then we do feature selection using correlation analysis. So we actually do correlation analysis on all the factors, 17 factors that we use. We actually found out that there are negative correlations between some of them, and there are mostly positive correlation with chlorophyll A. So chlorophyll A is the main indicator actually for algae blooming. So there is a positive correlation between turbidity with chlorophyll A. So there's some positivity there that can that would support our hypothesis just now. So after we have done with correlation, we go to the next stage, which is the model selection and evaluation. So we use data-driven approach. We use machine learning, deep learning, and time series forecasting. But the limitation of machine learning is that it's unable to extract features of multi-factor timing data. and it cannot reflect the temporal characteristic. So multi-factor means there's a lot of features there. So many features, and they are interrelated. They affect one another. So machine learning is not able to capture that scenario. I mean, to reflect in the results, and it cannot reflect temporal characteristic of the data. So what we do, the alternative approach is to apply deep learning and time series. So we have looked at deep learning, we look at RNN, and we look at LSTM, because LSTM it has shown outstanding performance to capture nonlinear and temporal behaviors. So this is the characteristic of LSTM. And because it can capture temporal behavior and nonlinear, and we have the problem of dynamicity and nonlinear of the algae data set, so it match. So we can use this. We try this on our data set, and basically LSTM actually solve these vanishing gradient issues. So basically the LSTM avoid losses, because that's why we call it long short-term memory, because it makes sure that the information does not get lost too much. Okay, so it always bring along the information in its cycles. So LSTM is very capable of capturing the dynamic features via cycles in the graph. Okay. And this is our result. The first table here, where we try machine learning methods, regression based on our data, and these are all the deep learning methods on our data. So you can see this is mean error, yeah, based on error. It's not accuracy. So mean error. The smaller the mean, the error, the smaller the value, the better. So in this case, you can see. The RNN, DNN, and LSTM is better. The error is the lowest compared to machine learning, because machine learning, they cannot capture the multi-factor and they cannot handle the temporal data. Okay, so that's the problem of machine learning. So when we compare our work with others' work in literature. So this is from literature. So number 12 is actually the work from previous researcher. We use the same data set like him. So this is a direct comparison. So based on his work, he used SVM for coastal, and when we use ours, we got lower mean error. Okay. For even though we use SVM here and we use we got 0.4, because we take more data from when he used it. He do it in I think 2000 something. So the data is like shorter than ours. We took until 2000 to the latest point. So we have more data. So that's the reason why this is slower than this. Okay. Okay, and then this is when we apply our RNN and DNN and LSTM. So the same thing here. Okay, so you can see that deep learning is able has significantly able to capture the dynamicity issues in algae prediction. But what is not captured by LSTM is this kind of spiking. Okay, so we need to work more on this to understand why is this sudden high peak is not captured by LSTM. This is in the future. So basically, LSTM has been able to has the ability to capture nonlinear fitting. And our features are enough input is enough for the predictive model to come up with the predictive model. And maybe in the future we will improve through the selection of significant features. We will improve this, make it smaller. Who knows if we can do that? Okay. So we have got the predictive model just now. So we have got our LSTM model. So what we need to do is we just need to put it here in our predictive modeling in this platform, and we can actually predict the next 10 days. And we have been able to do so for the turbidity sensor, but the validation is still pending. And what I have here is just an to show you the evolution of our census kit. This is our first setup, and now this is our setup, because due to the problem that we are facing with the wave and the currents, so we now use pump base. We will pump the water into this set, and then we'll do the readings from here. So we wouldn't risk of losing our equipments. Okay. So in conclusion, these are all the conclusions that we have. Since algae issues are highly nonlinear uncertain, so we need we need a robust predictive modeling to tackle the end-to-end process. And selecting the right features are crucial, and to tackle the dynamic issues and the dynamicity issues of the algae ecology. And LSTM with the right features outperform the other methods, and it graphs the temporal behavior and tackle the dynamic issues. And besides, we have in this study we have actually excluded meteorological factor and more chemical factor. So if we add this more, then we have no, with current situation we use less, we already got a good result. If you use more, maybe we can get more results, but this is enough. Like we said, with what we have is enough already. So this is the paper, the work presented here. It comes from this paper, the work that we have published this year. So this is my student who did this work, Nur Akila Pascal Rostam. So she is the one who is working on this. So with that, thank you.
Thank you, Dr. Nurul, for giving us insight about deep learning implementation in ecological. Now, because we only have very short time for Q&A, so maybe just one question for two presenters. If any of the participants Pak Chandra, maybe you will ask something.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Anusa and Nurul. Thank you for very great presentation. It's very insightful. I have a question first to Anusa. Research in computer vision, AI, machine learning applied in medical images is very interesting. I want to know what is the key challenges or the key successful thing to implement machine learning in medical image, because medical image is not like you find an image in the website, right? Website we have thousands or millions cat and dogs images, but in medical image we have limited images. And what do you think the key challenges and the key successful thing to implement AI and doing research in computer vision? I think that's my question. Thank you.
Okay, thanks, Chandra, for the question. Yeah, you hit the right question actually. You know, when we are doing research on medical application, I think you have already named it. The challenge is getting the data set. It's not easy actually. It's not like from from Google, we can just go and search for images. It's not like that. So we have to, first of all, is to have a good partnership or collaboration with medical doctors, and getting medical doctors to be involved in research also is not easy, because they are very busy in the hospitals, right? So those they are doctors which are also interested into research. So like USM, we have a very good environment where we have a hospital, like a teaching hospital in another part of Malaysia, in Kelantan. So we have also medical doctors that actually also aware of research and what's happening in USM. So they kind of want to collaborate with us. So when we approach, they are willing to collaborate. But obviously, getting their time sometimes is very hard. So data set is there actually. So once you find your collaborators, you can get your data set. But the challenge is to have a continuous communication, to get them involved. For example, when you are segmenting something, structure, obviously the computer application or the method can segment it, but how accurate is that according to medical doctor perception? That is the challenge we need to capture. So the medical doctor obviously have to do the manual work of outlining the structure. So from that, I take a benchmark to match and see the accuracy with my results. So to get medical doctors to outline on hundreds of data sets, so that is a bigger challenge, to get the ground truth, we call that the benchmark data. So that is the main challenge now. But yet, yes, we have some collaborators willing to do that. And for some common problem, for like liver segmentation, even brain tumor, there are a lot also public data set being released by research communities. If you read research articles, some of the research centers have actually released to be used as a public data set. So usually when we have a method, we try to use this public data set actually. Yeah. Do I answer your question? Hope I answer it.
Yes, thank you, Anusa. I have a weekly research meeting with Bu Nurul, so I can answer in our forum weekly meeting, and I hope we can also collaborate in the future, Anusa, to do this AI machine learning in medical image. Yeah.
Sure. Feel free to contact me. Thanks.
Yep. Thank you.
Okay. Enough, Pak Chandra?
Yes, Bu, I'm done.
Okay. Because the time has passed 11 from 9, so I will close the keynote session. I will read some point from the two presenters here. First, artificial intelligence and machine learning is highly promising to benefit medical domain, especially in medical image analysis. Some noticeable implementation are liver segmentation, tumor segmentation, and subcortical structure segmentation. And from Bu Nurul, we see that machine learning is not only about creating method, but also extracting right features. And both AI application in medical application and deep learning application in ecological informatics, I think could improve quality of our lives. So once again, we are very appreciate to Anusa, Dr. Anusa and Dr. Nurul. Thank you very much for your very interesting presentation today. Thank you, and I pass again the session to Pak Fatur. Thank you, Pak Fatur.
Okay, thank you very much, Dr. Sri, for leading the keynote session today. And we will move to the other session. We are at the student presentation session, and I would like to invite Wasapon Watanike Sunton, or Boom, to lead this session. Boom, the time is yours.
Okay, and thank you very much, Father. And I would like to start the student presentation sessions. And okay, can you see my screen right now?
Yes.
Oh, I think it's not that screen. Okay, maybe this one. Okay, and this is the student presentation sessions, which is our. I would like to start these sessions now. And today we have the 8 presenters today from the multiple universities. Here is the schedules of our sessions today. And first, I would like to invite Mr. Kanchanasit Thonglek from Nara Institute of Science and Technology, Japan, and he will present the first session. The Federated Learning infrastructures for collaborative machine learning on heterogeneous environments. Before that one, I would like to talk about the presentations. Each student will have to talk about 5-minute presentations, and they have a 2 minutes Q&A. I will be notified the times to the presenters via the chat, and I will type it to you via the direct message, and to inform you about the time, and I will try to notify you when the time is up. Okay, then I will start the session now. And okay, Mr. Kachanasik, could you share your screen and start your presentations?
Okay, hi. Thank you very much, Mo, for the introduction. Okay, should I start now?
Yes, you can start.
Okay. Okay, hello everyone. I am Kachanasik Thonglek from NICE. Today, I would like to present my proposed project about the federated learning infrastructure for collaborative machine learning on heterogeneous environment. First of all, I will introduce the collaborative machine learning, which is the development of machine learning model collaboratively by sharing datasets and model among machine learning developers. For this example, this use case scenario, there are 3 hospitals, A, B, and C, where we would like to develop the machine learning model to identify the suspect cancer from CT scan image of the patient. In the traditional process, hospital A and B will share the data to the server, and then the server have a service to train a model based on the datasets from hospital A and B. After that, hospital C can download and use the model from the centralized server. But this process makes the data loss prevention privacy because of transferring the data to the centralized server. Important thing, the CT scan image of the patient is a privacy sensitive data because it belongs to the patient. So that is another approach to preserve the data privacy for collaborative machine learning. It's called federated learning. The federated learning is a machine learning technique that trains the model across multiple machines, without exchanging local datasets. The federated learning was introduced by Google in 2016. It starts from the client can download the global model from the centralized server, and each client trains the global model by their datasets on their local environment. Next, the trained model is transferred to the centralized server. The important component in federated learning is a federated learning algorithm, which is used to aggregate the local model and global model together to update the global model. And then the other client can download and use the aggregate global model from the centralized server. But in the real world application, for example, the AFN6 model, which is the state-of-the-art model to identify the suspect cancer from CT scan image. The size of AFN6 is around 36 GB, but not every machine has a sufficient hardware resource that can support to execute AFN6. Therefore, federated learning on heterogeneous environment is still challenging today. So we aim to build an infrastructure that enables collaborative development of machine learning model on heterogeneous environment. The proposed infrastructure will similar to the GitHub or Docker Hub, which allow collaborative development in source code and container images, respectively. The proposed infrastructure has a model repository. For example, there are 3 machine learning developers. the first and the second developer train the model by their dataset on their local environment, and then commit the model to our proposed infrastructure. And the other developer can request and pull the aggregate model to influence with their own datasets. So the proposed project needs to address the technical challenge in federated learning on heterogeneous environment. We have to consider the limitation of each heterogeneous environment when we need to train or influence the machine learning model on client hardware resource. We divide the technical challenge into two main challenges. The first one is about the hardware heterogeneity. Each machine learning model requires different hardware resource for training and inference. And the second one about the software heterogeneity. Each machine learning model also requires specific framework for training and inference. Due to this technical challenge of federated learning in heterogeneous environment, we propose an infrastructure which contains 5 main components, which are able to tackle the technical challenge efficiently. For the first technical challenge, we will create the model compressor to compress the model to be compatible with heterogeneous environment. And the second technical challenge about the software heterogeneity, we will create the model trainer to build a container to train or influence model on heterogeneous environment. For this slide, show you the overview and design of our proposed infrastructure. In summary, to conclude this project, the proposed project will be conducted to support the collaborative development of machine learning. Due to the currently, there are no existing infrastructure to enable collaborative development of machine learning model on heterogeneous environment. So we will build a public infrastructure that allows collaborative development on machine learning model without sharing the datasets among users to preserve the data privacy, and also provide training and inference container for heterogeneous environment to prevent the dependency error, and extract the updated parameter from local model and sense only the updated parameter to reduce communication costs, and also compress the global model to be compatible with the client hardware resource to avoid insufficient hardware resource. That's all for my presentation. Thank you very much. Any question are welcome.
Okay, thank you very much for your presentations. Do anyone has questions? We have 2 minutes for the Q&A. Okay, then I have some questions.
Sure.
This project is for sharing the model or sharing the infrastructures between the users?
It's also, it has a sharing the model that for our developer community to improve the model performance together.
That means that the developers have to upload their own models into this system, and the others can be using this one. Others developers can using this one.
Yeah, the concept is like a collaborative development, such as the GitHub or Docker Hub, that you can upload your source code or your model, and the author can contribute your project.
Oh, okay, I see.
Yeah, so so it's good because in the model you don't have to do the training from the cache again, so you can use a P10 from our proposed infrastructure.
Okay, sure. And okay, that is all for me. Thank you very much.
Thank you very much.
And okay, and this is all for you. Thank you very much.
Thank you very much.
And okay, then I will go to the second presenters. The research is the title is the hyperparameters tuning based on grid search CV on mobile price classifications by the Dina Munana at the Universitas Nusa Mandiri, and she is here.
Excuse me.
Okay.
I will represent Mr. Dinar to present this paper. I'm the second author of this research.
Oh, I see. Okay, sure. Could you please share the screen and take the stage?
Okay, thanks.
Okay, thank you very much.
Let me begin. I will open my presentation. So sorry. Okay, can you see my screen now?
Yes, 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 I can see your screen.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Today, I will like presenting my paper. The title of my paper is the hyperparameter tuning based on the grid search CV cross-validation on mobile price classification. The first author, Mr. Dira Ismurandar, and the second author is me, and the third author, Mrs. Dizariana. We are come from the Universitas Nusa Mandiri, Jakarta. Our topic in this presentation, we have motivation and purpose of this research, research methods, and result and discussion, and then the last is a conclusion. Motivation, we need a model for help upon company to determine the price range of the cell phone according to their specification. The previous research by Papilia in 2020 has not produced the most optimal model to classification the cell phone price range. And then the research by Hasni and their friend in 2020 state there is a hyperparameter tuning technique that can improve the performance of the model. The purpose of this research, we're using a traditional machine learning algorithm. We're using a 5 algorithm, our dataset from a public dataset, a mobile price classification dataset, and then we're using a hyperparameter tuning to the traditional machine learning algorithm. We're using logistic regression, Kainer's neighbor, support vector machine, decision tree, and gradient boosting. And then we want to make it a comparison from this 5 algorithm. We want to find what kind of the model have the best performance. Our data set has 2,000 of the instance and 21 feature. We're using it for this research. And this is our research methods. Our training data is the 80% and our testing data 20% with the traditional machine learning algorithm. And this is the right side is the hyperparameter tuning. And we want to find the best classification model performance evaluation based on the confusion matrix, accuracy, precision, recall, and F1 score. The result and discussion. So this is the traditional algorithm, logistic regression, and this is their hyperparameter value from the grid search and cross-validation. We find this recommendation from this method, cross-validation research. And as you can see at this right side at the table, you can see the a distance. It has a long distance between execution without a hyperparameter with the with hyperparameter. As you can see, it is the first record. First line, logistic regression is just get 64.5% the accuracy without a hyperparameter, and after we using the hyperparameter tuning, we get 66% or the accuracy. Until to the gradient boosting, we get 93% accuracy. And our conclusion at this research, we can say that the best model for phone price classification without hyperparameter tuning is obtained by support vector machine with accuracy 95%. And then after using the hyperparameter tuning at the 5 algorithm, the best accuracy is obtained by logistic regression with accuracy 99%. And at this research, we can prove that hyperparameter tuning can improve performance on each model build. And I will say thanks. This is our reference at this paper. I think I'm finished for this presentation. Thank you very much.
Okay, thank you very much. And anyone has questions for the presenters? Okay, then I am going to ask the questions. What is the result of when you get it? Or is this classifications anything?
Yes, this is the classification, this prediction with using hyperparameter with 5 algorithm. This research will make a comparison between 5 traditional machine learning.
Okay.
The classification about cell phone price range, we are using a public data set from Kaggle.
Okay. Thank you very much. And then I see. Okay, that is all for my questions. I think I see Ichiko Sensei raising his hand. Could you please ask the questions?
Will mute.
Ichiko Sensei, do you mute your microphone?
Sorry. So what is the size of the hyperspace size? So what is the range of the parameters? So how many tries you have done to search the best parameter?
How many? The range of the cross-validation.
Yeah.
Okay.
Range of the space,
the cross-validation, we have some value for. Okay, I will share my screen again. Okay, I'm gonna move to the. Okay, for this, we're using some value from. I'm sorry, I will show you something. Please wait for a moment. Okay, let's wait something. Okay. I will share my screen again. Okay, and this is the result of my partner using KNN. As you can see, the range of the neighbor, like Kenner's neighbor, we're using range 1 until the 13, and for the weight, we're using uniform and distance. And the system from the grid search will be select which one the best hyperparameter for the algorithm. And then if we move to the logistic regression, I think you can see we have some parameter here: Newton CG, SEG, SEGA, and LBVGS. We have some option, and then the system select the best hyperparameter using a grid search cross-validation method.
Okay, thank you. Yeah, so you search the many combinations of the parameters, right? Okay. Thank you.
Okay, thanks for your question.
Okay, and thank you very much. And this is all for your presentations and questions. And I would like to pass to the next presenters. Thank you very much. Okay, the next presentation is the text classifications for systematics literature review using machine learning. Case study of the relations between the endontalisms and comorbid disease. Could you please, Miss Kat, could you please start your presentations?
It's cute fun.
Oh, okay. Sorry for my.
That's okay. Can you see my screen?
Yes, we can see your screen.
Is
please
my
start
voice
your presentation. Clear? Yes.
A minute. Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Jut Aisyah Yunan, and today I would like to present my research on text classification for systematic literature review using machine learning, case study of the relationship between edentulism and comorbid disease. This research is a multidisciplinary collaboration between me and Mr. Chandra Prasetyo Utomo from Faculty of Information Technology, Universitas Yarsi, with Professor Cortina Sukojo from College of Dentistry, University of Illinois, Chicago. So here is what we are going to talk about today. We'll go through it one by one. Why we do this? First of all, literature review is important for clinicians to keep abreast of new techniques and make better decisions for the care of patients based on best available evidence. That's why doing a systematic literature review is important in medical fields. But the large number of data, the time and human research it takes often becomes the challenges. So what others have done, this is what others have been doing in the past 3 years. The exponential growth of data opens up opportunities for the state-of-the-art approach such as deep learning and transfer learning to solve this problem somehow, but somehow it has not been explored yet. So the objective of our study will be to build a machine learning model to automate the screening process of systematic literature review and explore the potential use of deep learning and transfer learning. To give you guys the bigger picture of how the screening process of SLR, we have the comparison here. So with manual screening, after we identify records through research strategy, we have to do double or two-step screening process by title and abstract and by full text. But with AI, we can combine these two steps into one to define which articles to include and to exclude for SLR. How we do it? So first of all, we retrieve records from keyword search in search engine and online journal, and then we manually screen and classify it into included and excluded articles. After that, we extract the text and split it into training and validation set. The training set will go through experimental machine learning model selection and test it with the validation set. After that, we can get the evaluation result. If we have more records, then we repeat the process. If we don't have more records, then we can start the data extraction process for systematic literature review. So for now, we have 44 collected data, 22 from each class from the previous systematic literature review in the same case study and keyword search. We tried 3 different types of approach from conventional, deep learning, and transfer learning. You can see in the table, we have naive-based, SVM, dense, and 3 types of recurrent neural network, convolutional neural network, and from transfer learning, we use TensorFlow hub pre-trained model combined. And so here result, and go to in the next slide. So the evaluation result shows that SVM outperform the other methods with 100% accuracy, precision, and other metrics. And in title and abstract screening, bidirectional ASCM is the number 2 highest performance with 91% precision and 88% accuracy. But in the more length, more text, it is TensorFlow hub pre-trained model with 91% of precision and 88% of accuracy. So the conclusion of this research for now is that our research aims to build machine learning models to automate the screening process of SLR. The results of this study are expected to shorten the screening process and reduce the workload of researchers in conducting SLR. We have explored the different algorithms from conventional machine learning, deep learning, and transfer learning. The current experiments show promising results for the use of deep learning and transfer learning in classifying text for systematic literature review. I think that's all from me. Do you have any questions?
Okay, thank you very much. And anyone has a questions? Please raise your hand or type in the chat. I can read it to ask to the presenters. Okay, then if no one, I would like to ask that where do you get the data set?
Oh, it is a collaboration. So we asked Professor Cortino and his students to generate the data set for us.
Oh,
So
okay,
they do
that's mean the all of the is generated data, not corrected. Okay, I see. Okay, thank you very much.
You're welcome.
Okay, then if no one's asking more questions, I would like to pass to the, I would like to go to the next presenters. Okay, thank you very much.
You're welcome.
Okay, hi. The next presentation is the artificial intelligence to predict the dental student academic performance based on pre-university result. This is a presentation from Adilat Saihila Abdullah, okay, from International Islamic Universities, Malaysia. Hi, could you please start your presentations?
Okay, hello and good morning, everyone.
Yeah, I can see your screen and we can hear your voice.
Yeah, my name is Adila Shaira. I'm from Faculty of Dentistry IIUM Malaysia. So today I will be presenting my research proposal on the topic Artificial Intelligence to Predict Dental Student Academic Performance based on pre-university results. So for introduction, admission information has historically been used as predictor of academic success in dental school, especially for the first academic year, to identify students that may be at risk of low academic performance. Secondly, failing course or year is one of the common stressing problems faced by dental students, which can affect their mental health. Third, based on previous cohort studies on other programs, pre-university performance does not affect students' academic performance due to pre-university results is an unmodifiable factor once they enter university. However, the study only comparing the academic performance between pre-university and university level without considering other factors that may contribute to students' academic performance, which are students' ability, referring to soft skills and language proficiency, prior academic performance such as pre-university results, which will be highlighted in our studies, demographic factors, as well as psychological factors. So previously, there are many observational studies that has been conducted to compare and correlate between pre-university and university academic results. However, there is a very limited study on the prediction of academic performance using AI has been conducted. So before going to objective, I would like to explain about data program admission criteria in Malaysia, which requires students to have 1 or 2 pre-university preparatory program as listed. About our program, Bachelor of Dental Surgery IIUM, it is a 5-year program which divided into 2 phases. Phase 1 is preclinical and phase 2 is clinical phase. So basically throughout all the 5-year program, all the courses will be assessed in exam manners through 4 professional exams. So moving on to artificial intelligence, it is a branch of computer science concerned with building smart machines that can perform tasks which typically require human intelligence. So machine learning is the ability for the machine to learn information and the patterns directly without being processed explicitly, and it has 2 types, supervised and unsupervised learning. So our objective is to apply AI to predict academic performance of dental students based on their admission results. So specifically, we would like to provide data set as input from social demographic pre-university and pre-university records. We would like to also build a model that matches input data into the expected target values. And we would like to give a training set consisting input and the output that will determine the success of dental student. And lastly, we would like to predict the potential of academic performance based on the given input. Okay, so moving on to the materials and methods, we will obtain ethics approval. And for the study design, we will be using machine learning algorithm. And the study participants will be from dental graduates Kuliah of Dentistry IIUM from 2016 to 2021. Okay, for data collection, the data will be collected are demographic data as listed, and academic records such as pre-university CGPA, professional exam results, and final CGPA that is included as input data. Okay, these are our exam grading system. Okay, the variables that will be included as output data are number of repeat paper, meaning that the students fail during their professional exam, so they will have the chance to seek for remedial exam. That remedial exam is repeat paper. If they fail in the remedial exam, they have to repeat the whole course of that year, so they have to repeat year so they can advance to the next academic year. Number of distinction, meaning that how many times they got an outstanding marks in the exam. Graduation on time, meaning that they managed to complete their study within 5 years. Okay, for experimental for data understanding phase, we will perform the exploratory data analysis to find the pattern and important insights. And that for data preparation phase, we will divide the data into training and testing data, and we will perform data cleaning also. For modeling stage, we will train the several prediction models using machine learning algorithm. And lastly, we will, for evaluation stage, we will compare the predicted values with actual values to compute for the accuracy and prediction errors. Okay. For final stage of data analysis, we will calculate statistical summary for each variable. We will visualize the data. We will compute correlation coefficient to find correlation between variables. And lastly, we will compare the prediction performance using performance metrics. So at the end of our study, we will expect to be able to predict the academic performance of Kuliah of Dentistry IIUM students based on their admission results. These are our thank you. That's all for me.
Okay, thank you very much. And please, if anyone has questions, please raise your hand. Okay. Sri, I think I saw Sri is raising her hand. Could you please ask?
Thank you,
questions?
Bo. Yeah, thank you. I forgot the name. Yeah, I want to ask, what do you think your method can also predict academic performance for other study program, not only a dental student?
I think it may help if they have sufficient input data, so can help in the accuracy of the machine learning to predict.
Is there any something special variable or your research for dental students? So what is the maybe any special variable for you that will be different for other program study?
Okay, for our study, it requires excellent CGPA for pre-university compared to other courses, I think, and maybe other demographic factors like the parents factors other demographic data may influence the prediction.
Okay, thank you.
Okay, and thank you very much. And due to the time, we need to go to move on to the next presenters. Okay, thank you very much. And okay. Okay, then I would like to moving to the next presenter. The topic is the automatic detections of plant disease on eucalyptus pellita leaf by using a deep learning model method by Deviana Selivita from the Universitas Nusa Mandiri. Could you please start the presentations?
Okay, thank you. I will share screen.
Okay, please share and start your presentation.
My screen is out or?
Okay, yes.
Yes. Okay, I'll show. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Let me introduce myself. My name is Deviana Selewita, and the second author is Agus Bukti. I will present about automatic detection of plant disease on Eucalyptus pellita leaf by using the deep learning method. I will explain first introduction and proposed method, result and discussion, conclusion, and the last is future work in this research. Significance, Indonesia is sick hikers, pulp and paper industry, and Eucalyptus pellita is a raw material resource for the industry. The tree is cultivated in industrial plantation forests in Kalimantan and Sumatra. Eucalyptus pellita belongs to the Myrtaceae family and is one of the priority species for industrial plantation forest. It's a good tree should include fast growth, a straight tongue with limited branching, and controlling the Eucalyptus pellita disease is vital to ensure the good harvest. The problem is currently disease detection in the plantation is performed manually, so it's not effective due to the limited number of experts. And if there is no expert, unskilled field laborers take the image and send to the head office to get further instruction. So in this research purpose method, first time I will collect the image. So the data image I collect to process at machine learning with model VGG16. That is and model that utilizes a convolutional layer with a small convolutional filter specification to classify normal class and disease class. We can see that different of the picture, these leaves normal and healthy and sick. And the data set, we use 756 image healthy and 680 image of disease image leaves of Eucalyptus pellita leaves. And the data set will collect from PT Surya Hutani Jaya, Sebulu District, Site 32, Kutai Kertanegara Regency, East Kalimantan Province, Indonesia. And the result with VGG16 with fine tuning was performed on several layers of VGG16 to optimize its performance on the Eucalyptus pellita dataset. There is a graph of trend loss, accuracy, and this is with total of 20 epochs. The experimental results show a fairly good accuracy, reaching 90%. We can see in the precision, recall, advanced score spot accuracy 90%. And then we can conclusion, fine-tune VGG16 deep learning model gives prospective performance for Eucalyptus pellita disease detection. Its accuracy 90% for the collected data set. And for the future, we can detection of the types of disease of Eucalyptus pellita, multi-class classification, because in this research, just healthy and disease leaves, not classifies what the type of disease. So we can detection a multi-class classification with the different disease. And the second is system deployment for this research. Okay, just it's my presentation. Thank you for your attention. If any question, please.
Okay, thank you very much. And do anyone has any questions? Please raise your hand. You can type on the chat. Okay, Jason, and Jason is raising his hand. Please ask the questions to the presenters.
Yeah, I just had a quick question. I guess it wasn't, I might have missed it, but it wasn't clear, how do they use the information then? Like when you actually deploy this, so they know, so after they figure out whether the leaf is diseased or not, then what do they do? Like what's the idea? Like what actions do they destroy the plant, or I mean, you know, that type of thing. Like how do they use the information?
Okay. Yes, thank you for your question, sir. In this research, the next project is for classification the disease. For this time, this is just for classification healthy and not healthy or not disease sleeps. So in the next step of this research is for classification more disease. That's more more wanna help worker in there to with this feature and with application. The next step application project, they just take a picture and then result what the kind of this disease for the next project in this research, sir. You get that or not clear?
Yeah. Thank you very much.
Thank you.
Okay, and thank you very much, Jason, and thank you very much, Devina. I think that we have to move to the next presenters.
Thank you.
Thank you very much.
Yes, you're welcome.
Okay. The next presentation is COVID-19 diagnosis using a CNN from scratch with the negative transformations and Gaussian low profile filters on chest X-ray image, and by the Ashma Dino Suputra. Hi, could you please start your presentation?
Sorry, I will be presenting in place of Dino Saputra.
Okay. Milata, right?
Yes.
The second presenters. Okay, please start your presentations.
Can you see my screen?
Yeah, we can see your screen.
Okay. Good morning, everyone. My name is Milata Hanifa. Today I will present about COVID-19 diagnosis using CNN from scratch, negative transformation, with negative transformation, and causal low-pass filter and chest X-ray images. This is research from Ahmadina Saputra, Milata Hanifa, Yasin Alfi Yahya, and Mr. Chandra Prasetya Utomo from Faculty of Information Technology, Universitas CRC. Okay, today I will present four topics. First is motivation of our research. Second, the workflow we use. Third, the result of the model we made. And the last is conclusion. Okay, let's start. The first topic is motivation of our research. COVID-19 is a disease caused by the SARS-CoV-2 virus that causes mild, acute respiratory illness to death. The virus has also caused pandemic around the world. Until now, the COVID-19 pandemic is continuing, and this is the COVID-19 situation in Indonesia on 8 December 2021. Positive confirmed patients are still increasing, and on that day, there are 264 cases confirmed. This is a challenge for medical staff, especially radiologists, to analyze the X-ray result of patients in large quantity to detect COVID-19, which certainly takes a long time. So we are trying to find a solution to detect patients infected with COVID-19 more efficiently and effectively using a machine learning approach. Because by using machine learning, first we can save radiologist time in analyzing patient X-ray. Two, the patient diagnosis process can also be faster and of course remain accurate, because machine learning can analyze a lot of data stably in a short time and can reduce human research, human error as well. And with machine learning, we can reduce the workload of radiologists too. This is the workflow we use in our research. In this research, we use just X-ray image dataset available online, and we divide into three classes: COVID-19, normal, and viral pneumonia. Then the data was split into 80% data training and 20% data testing. Then the data is processed using negative transformation and Gaussian low-pass filter. After that, we create a model. We try to create a model using CNN that we built from scratch, because in previous studies, many researchers use CNN plus transfer learning, so that we try to build our own model. And in the study, the model will be evaluated using a confusion matrix to see the value of precision, recall, and F1 score in each prediction class. This is the performance result of our model. It can be seen in the table. Using negative transformation and Gaussian low-pass filter as an image preprocessing technique and also CNN as the model, the result obtained are 95% accuracy with an average precision of 95%, recall 93.3%, and F1 score is 94% with a total test data of as much as 3,032 images. Result on this result, the technique used in our research is considered quite effective and also has good performance, even though the image dataset is not evenly distributed. This is our highest professional result, and we believe in the future we can still improve the accuracy of the model we built. And this is the conclusion. The COVID-19 diagnosis model using CNN with negative transformation and Gaussian low-pass filter on chest X-ray images was successfully built, of course, with a good accuracy and performance. Based in this, our model has the potential to be useful to have medical staff, so to save time, accurate diagnosis, and reduce the workload of experts. Thank you. This is my presentation. Any question?
Okay, thank you very much. And do anyone has questions? You can raise your hands and ask the questions. Okay, I would like to ask about how to dealing with the results. Did you already apply when you get the result? How do you continue to do that? Do the results? How do you process? How do you handling it? Do you apply it to check in the real life or something?
This is the result. And if possible, we also want to deploy our model to a mobile application so that it can be used by medical staff. But for now, we want to try to do hyperparameter tuning on our model to get better performance than before.
Okay. Yeah, I think that is a very interesting research. That is about dealing with the COVID. Okay, then thank you very much. And this is a great presentation. And okay, I would like to going to the next presenters because of the time. The time is limit. And the next presentation is the convolutional neural network for genders and accent recognitions of speech, of human speech by Father Raman. Could you please take the stage?
Thank you for attention.
Okay, and okay, could you please start the presentations?
Yes. Thank you. Good morning, everybody. My name is Fatur Rahman and secondary author Agus Subekti. My name Fatur Rahman from Nusa Mandiri University. I will presenting a result of my research contribution entitled Convolutional Neural Network for Gender and Accent Recognition of Human Speech. For next, the topic of the research conclusion yaitu 1. Introduction, purpose, method, result, and discussion, and conclusion. Analyzing the human voice has always been challenged to the considering society for various purposes, such as review, emotional state detection, developing IEA, and much more. One of the challenges of identifying a man or women is important. We can know the geographical area in terms of language, culture, and where the human come from and live. Collect a data set of human speech, 6,000 male and female voice with different accent and by geographic area. Standardization before the dataset in use, resampling of sample rate, bit depth, channel, and duration. Spectrogram and MFCC, I use pre-emphasis, frame blocking window, FFT, male frequency warping, DCT, several filtering. Perform modeling on dataset that have gone through the features extraction process to get the best model on data trend and validation. Gender recognition and action, calling the best model on data trend data, dan validation for testing the gender and accent classification. 3,000 of SLR 95 and 3,000 of common voice dataset are quite new to use, and it can be seen that the result obtained for the architecture model and hyperparameter that have been made get the best accuracy, gender class width 96.2025, accent class width 99.25. Here, 250 epochs where I conducted trend data and validation of gender and access classes. Precision recall and F1 score on testing data obtained from testing the base model on the trend validation obtained, an average accuracy of 96.25, and gender class. Precision recall and F1 score testing data obtained from testing the base model on the trend validation obtained, an average accuracy of 99.25 in the accent class. The accuracy of previous study was obtained with the highest result in the gender class, 93.11, the accent class, 11.07. The following are the results of the testing of voice, the author original voice by building a flux model application using the best HDF5 model in trend data, then validation for retesting the classification in gender recognition. In the study, feature extraction of 6,000 wave and MFCC and spectrogram with 2D CNN and can recognize gender and voice accent combined dataset consisting of 3,000 dataset and 3,000 common voice success in obtain 96.95% gender and voice accent with accuracy 99.95 accent. This method works better on separate data accurate data in gender and accent classification. Thank you for attention. Any question?
Okay, thank you very much for your presentations. And anyone have any questions? Okay, I saw Nan is raising her hand. Could you please ask the questions?
Yes. So you got the open data, right, for US and UK accents? This is the open data, right? It's not
Yes, for a minute, open data.
Okay. And do you think the approach will work well if you do like apply the model with the Indonesian people data as well? To rephrase the question?
mungkin bisa bantu menjelaskan kalau ini dipakai untuk aksen Indonesia, kira-kira hasilnya sama nggak?
Oh ya, oke, in this section.
Nggak apa-apa, langsung dijawab aja. Kira-kira apakah hasilnya sama bagusnya atau bagaimana gitu?
Oh ya, and in this section. In this testing with the result Indonesian, it just as good. For example, running model flux with general classification and class model accent. I want share screen. Yeah. And so wielding my voice classification, gender accuracy, male prediction accuracy, 98.54%, female prediction accuracy di 1046%. Thank you.
Okay, thank you.
Okay, thank you very much, and thank you very much, Nan, for the questions, and thank you very much, Father, for your presentations and your answer. And I think this is all for your presentations. Thank you very much. I would like to move into our last presenters, which is the title is design of the prediction system for calculations of the width of the central incisors with linear regressions with from the Y Mustikara. Sorry. Hi.
Yeah,
Thank you very much. And could you please start your presentations?
okay, wait a minute. Can you see my screen?
Yes, I can see your screen.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Dwi Mustikasari. I would like to present my research about design of prediction system for calculation the width of the central incisor with linear regression. This research is collaboration between me and Mr. Chandra Prasetyo Utomo and Professor Cortino Sukojo and Mrs. Murphy Konsoglu. Okay, some of topic that I will discuss in this presentation are: first, we will talk about introduction, and second, we will talk about research method, and then we will talk about experimental evaluation, and then we will talk about implementation, and the last is about the result. Introduction. More than one facial measurement will be used to determine the width of maxillary central incisor, that is the incommensurable width, and then the interlateral width, and then the intermedial canthus width, then the interlateral canthus width, and then the interpupillary width. Then it's also the necessary to measure the width of maxillary central incisor. To rehabilitate the endothelial patient with aesthetic interest according to anthropological measurement available on the face. The width of central incisor remains contained throughout life, whereas the length may change due to wear, making CW a more reliable dimension. These sizes were chosen because this measure will remain stable to life and do not show significant change with age. After the required size have been collected, then a research relationship between this size is carried out to make prediction of the value of maxillary central incisure that is useful for manufacturing of dentures. In this study, me as the author makes a machine learning model to determine the value of the maxillary incisure by using linear regression algorithm. Research method, linear regression. Regression is a method in the model that is used to predict a value derived from the data entered. The predict value with dependent variable, while the data entered will with the independent variable. The method of determining the regression of the relationship between one or more dependent variable or X and one independent variable or Y. Or Y. Linear regression has two types based of number of variable. The first is multiple linear regression, and the second is a simple linear regression. Which means multiple linear regression looks for a relationship between one dependent variable and two or more independent variable. And then simple linear regression is that look for relationship between one dependent variable and one independent variable. Okay, this is the example of my dataset that will be used in the study. The dataset that I show you is the dataset that's still an image and has not been carried out that in feature extraction process. There is a image of human face and the image from the human teeth. After vector extraction, the data will be obtained in the form of table containing 5 independent variable. This is the independent variable and one dependent variable measurement that total data that I use is 214. The step that I did in the implementation were first importing the package, and then we will import the data, and next is data visualization, and then we will data processing, and the data will I split into two size 18% for 80% for data training, which is for the modeling, and then 20% for data testing for data validation. The result that I got in this study, I have described in this following table, which is in this table we can see the best result obtained in the method are by linear regression. Method with the root mean square error is 1.99 and the present correlation coefficient is 99%. Okay, this is the end of my presentation. If there is a mistake, I apologize, and if anyone asks, please. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay. Thank you very much for your presentations. And if anyone has any questions, please raise your hand. I have a very quick question, Saha. Did the data that you get it do you record it and you record the data by yourself?
Okay, because this is collaborative research, I got the data from Mrs. Murphy, student in Turkey.
Ah, okay. that they recorded it and provided data
Yeah.
from you for you.
Yeah.
I see. And then after you get the result, how do you handling the data? How do you handling the result? What
Okay.
how about applying the real world or the test case or something?
Okay. In this picture, there is a CW measurement. That means it can be dentist for making the artificial teeth.
Okay. I see. Okay, that is a very interesting research. Thank you very much.
Thank you.
Okay, thank you very much for the presentations. Okay, and this is all of the student presentation sessions. This is all of the 8 presentation sessions, 8 student presentations. And thank you very much everyone for attending these sessions. And thank you very much to all every presenters. You have a great job. Thank you very much. And this is all for me for today, and hope to see you if we are in the next Pragma student workshops next time. Thank you very much.
Okay, thank you very much, Boom, for leading the student presentation session on time. And our next agenda is the student workshop session, and we have 2 break rooms. At the break room number 1, the workshop will be talk about the cloud technology delivered by Prapapon Ratana Thamrong from Thammasat University, Thailand. And our student, Chut Aisa Yunan, would be the session chair. In another breakout room, room number 2, there would be a workshop will be delivered by Chandra Prasetyo Utomo and Muhammad Tatur Rahman. It's me. Yeah, we will talk about the deep learning using TensorFlow. And our student Rara will be the session chair of this workshop. Okay. One thing, we would like to remind you that after the workshop session, please return to the main room because we have an award and closing remarks. We would like to give announcement about the best student presentation at Pragma Student Workshop 2021. Okay, we will hope that you will enjoy the workshop today. You can join the break rooms now. Thank you very much.
Father, I have a question. So yeah. should I be in the committee room first before going to the breakout for cloud?
Oh, you can directly go to the cloud breakout rooms. Break rooms number 2. Sorry, break room number one. Okay.
Okay, so I don't need to talk to other committee on the student presentation result, right?
Yes.
Okay, all right. There seems to be no join button for me to go to room 1. Would it be possible for you to assign me to the room?
You may to navigate your mouse at the right, on the right of the name of the breakout rooms. You can see the number of the participant, and that would be a assign button or join button. Can you see that?
No, there's no join button on mine.
At the name of the rooms on the right, on the right, you can see the number of the participant.
Yes, I can see the number of participants.
Just then you just navigate your mouse, your mouse cursor to the number. Okay, it would be a join button, I think.
I saw it before.
If you can, but you can join. We would like to.
Okay, I saw it now. Just come up now.
Okay.
Bu Umi, Nan ikut ke komite dulu atau langsung ke itu? Kalau ke komite nanti takut waktunya nggak cukup ya?
Yeah.